All right, welcome everybody. I give folks a few minutes to join. We'll get started with a quick intro before we head into today's topic. All right, awesome. Looks like we've got a good amount of folks jumping in already, so I'll go ahead and get started. My name is Bo. I'm here with Acelab. We are helping out with hosting today's event presented by the great folks at the Steel Tube Institute. We've got Ryan Jackson on today, who's going to be giving today's presentation, and Dale Crawford here as well to help out with any questions that folks might have. So I'm going to get started with a quick little intro about Acelab, show you guys how to find some more information about the Steel Tube Institute on Acelab. So if you want to get some more details after today's event or get in touch with them directly, our platform is a great way to do that. And then we'll go ahead and get started with today's webinar topic. All right, so anyone who signed up for today's webinar automatically has a free Acelab account made for them. I'll launch a short poll once I'm done with this. So if you're interested in learning some more about all of the free tools and resources that we offer, you can sign up for a quick demo with someone from our team. That's totally free. They'll help you out with, kind of getting all set up and getting onboarded. Today, just want to focus on showing you how to get in touch with the folks here. So if you use the search bar at the top of our page, you can type in the name of any product, any brand, manufacturer, really a bunch of stuff you can search on. It'll cross-search between categories, brands, and resources. So if you make sure you're on the brands over here, you can head over to the Steel Tube Institute's page on Acelab. You can use this button to get in touch with Dale directly. That'll create a message for you and Dale where you can talk with him a little bit more about some of the questions you might have. You can also explore some more about the Steel Tube Institute, some of the values and resources that they provide for architects and engineers, watch some videos and get some inspiration. If you do come here and click contact with Dale, that conversation will get created. You can find your conversations over here in your Acelab account. You'll also get an email notification anytime you have a new message, so you don't have to kind of come back and check this all the time. But all of your conversations can be found here. You can nest them under projects. So it's a great place to, keep all of your research organized. One quick thing I want to share about some early access stuff we have coming up. So if you're interested in gaining some early access to some of our newer tools and resources, we're going to give you the option to do that during today's event. So this is a quick preview of something that we are recently launching for architects. This is some updated stuff, some stuff that already exists. Really what I want to focus on here is this schedules tab. So we are releasing this to some early access beta testers. If you're interested in doing that, you can just respond to the poll that I'll put up momentarily. Basically, this is a great place to keep your digital product library organized in Acelab. You can add data from Acelab's platform to automatically fill things out. You can also add any number of custom data that you want. So it's a really flexible system. You can use this to share with your clients, with contractors. You can also add team members so you can collaborate all in one place. And you also have the ability to get in touch with reps directly from this platform. So it's a really great place to keep all of your organization kind of in one place and collaborative and fully accessible to your team. You can tag things with, office locations, assemblies, reference photos. You can comment back and forth. So if you're interested in learning some more about Acelab and how to use some of our newer tools, I will release a poll right now and just feel free to say yes. Someone from our team will reach out to schedule a quick 15-minute session with you. All right. Other than that, I just want to encourage folks to please submit questions to the Q&A throughout today's presentation. We should have some time to get to those questions towards the end of the webinar, but if we do not get to your question live, we'll have a record of it and we can follow up with you after today's event. All right. Other than that, just want to thank everyone so much for joining today. We appreciate you coming out to learn some more. And Dale, Ryan, whenever you're ready, feel free to give a little bit more introduction about yourself and about the Steel Tube Institute and get started with today's topic.
Okay, great. Well, while Ryan's pulling up the presentation, he'll be our presenter today, but I'm Dale Crawford. I'm the executive director of the Steel Tube Institute. We're a trade association representing steel tubing manufacturers, and we've been around since 1930, so we're coming up on our 100-year anniversary. We have several sections of products that are linked together by the same parent companies that make this similar products, but our largest two are structural steel and electrical conduit, steel conduit. And so Ryan works as a part-time consultant within our electrical section, our steel conduit section. I say part-time because we couldn't afford to have Ryan full-time. He's too prolific of an author, of a speaker, and a national electrocode expert. So listen to what Ryan says. He is probably the foremost expert on the NEC in the country, and he'll probably argue with me on that, but I have come to believe that. Um, if you We have had a lot of signups for this, which we're very grateful for and happy about. But that tells me that we probably have some related topics that we need to also prepare a webinar for. So at the end of the call or within the chat, if there's some other topics that you would like us to dive deeper into in a forthcoming webinar, please let us know. And so that I'll turn the time over to Ryan.
All right. Well, thank you very much, Dale and Bo, both. Good to see you, and good to see all of you fine folks out there. I guess I say good to see you with air quotes, right? But we're going to talk about the National Electrical Code today. And when I was asked to do this, I was way excited because I do, oh, I don't know, 100 classes a year probably on the National Electrical Code. But then they said you got about 45 to 50 minutes, and I thought, oh my God, I can't do anything in 45 to 50 minutes. I normally teach 8-hour classes, so we're gonna jump in, and we won't be able to get our feet all the way in the water, but maybe just our toes into the water. So National Electrical Code for Architects and Introduction is what I decided to call this. Just a quick introduction. I'm Ryan. We're with the Steel Tube Institute. I live in Salt Lake City, Utah. I write books, I teach classes, and I'm just kind of a code nerd. That's what I do. I, consult and do expert witnesses and write books and teach classes. So I'm just kind of an NEC dork. I even have an email address and a YouTube channel and a phone number. So you can feel free to get in touch with me. Not trying to promote my YouTube channel, but there's, literally hundreds of free videos there. So if you can use it as a resource, then by all means use it. And if you want to reach out to me with a technical question, please don't hesitate to do that. I'll try to put my name, my email address and contact info in the chat room as well. Or Dale, maybe if you could do that for me while I'm going, and that way people don't have to try and take a screenshot of this or anything. Really quickly, some preliminary stuff. I serve on NEC code making panels 3 and 17, but I don't speak for the code making panels or for NFPA or UL or NEMA or anybody else. This is just little old me talking, right? All opinions are mine and mine alone. I also want you to know that on my slides, I paraphrase the text of the NEC. NFPA would not be amused if I just copied the code book and pasted it in slides and then sold it. So obviously it's paraphrased, but I do think I capture what the code is trying to say. So the actual text of the NEC should always be consulted. And on my slides, underlined yellow text is going to indicate a 2023 code change. One more thing before we jump in and start doing the technical stuff. I want you to know that this isn't a sales pitch, all right? You guys are smart people. You already know that you should be using steel conduit, right? I don't have to tell you that. So the reason we're here is to create a relationship. Yes, I would love it if you bought steel conduit, but we're really there to help you guys out. So if you have questions on the NEC, reach out. It's my pleasure to help out. So we're a resource and we want you to take advantage of us. So that's the whole idea of why we're here today. So with that said, let's go ahead and jump in and start getting into some of the technical stuff here, starting with Article 90. And really that's where we're going to spend a fair amount of today is just Article 90 and 110. The introduction, use and application of the code 90.2. Very first thing you read in the code book tells you why the code exists. It says the purpose of the National Electrical Code is the practical safeguarding of persons and property from the hazards that arise from the use of electricity. And of course, mainly when we talk about the hazards from electricity, we're talking about electric shock and we're talking about fire. So here in this picture, we're measuring, roughly 120 volts from the grounding terminal of that receptacle measured to the metal parts of the sink. Obviously something is extraordinarily wrong in this picture, and it's almost funny because it's so wrong it's almost comic book wrong, but unfortunately it's a real photograph, and this is the type of thing that we're trying to address in the National Electrical Code. Believe it or not, we ended up I say we, there were about 15 fatalities during the Gulf War from miswired barracks that resulted in a very similar installation like this. There were about 15 of our soldiers that in the barracks went in to take a shower at different buildings, different times, and ran into the situation and perished from it. So as bizarre as this is, it's not Photoshop. You know, this is a real thing, and if you screw up badly enough, you can create a situation like this and end up killing somebody. And that's why the code exists, right? The whole reason the code is there is to protect people from what? Electric shock and from fire. This is a picture I took probably back in 2003, maybe 2004, when I very first started teaching and was really starting to become a code nerd. I was working as an inspector in the Salt Lake City area, and a neighboring city, their fire marshal called and asked me if I could come and give an opinion on an incident that they had in their city. So I took a quick little drive, and this is what I saw. But what was really interesting about this is that this was a low voltage lighting fire. And quite frankly, the fire marshal couldn't believe his eyes, and that's why he called me. He said, I didn't think this was really possible." And it is possible. So that kind of thing is why the code exists, right? The prevention of electric shock and the prevention of fire. Now, there's a couple of interesting things here in 90.2 that are unique to the NEC that you don't see in the IBC and the IRC. This is kind of a passive-aggressive statement. The first thing you read, the NEC is not a design specification. Well, okay, I mean, your design has to comply, so yeah, it's not a design specification, but... And it also says it's not an instruction manual for untrained persons. It kind of says right off the bat, listen, if you don't know what you're doing, don't even read this book. If you're at that point in your electrical career that you think you should duct tape your lights to the beam as a way of supporting them, you know, maybe this book isn't for you yet. You know, maybe you need a more basic, you know, level 101 kind of book before reading the NEC. It's not your first book that you should read in the electrical industry. It also says that complying with the code will result in a safe installation, but that's where the promises end. It might not be efficient, convenient, or even adequate for good service or for future expansion. The only promises that we're making here is if you follow the NEC, it should be safe. You shouldn't kill anybody, shouldn't shock anybody, shouldn't light a building on fire. It might not be efficient or convenient or adequate for good service. I mean, here's a picture that I took during an electrical meeting. There weren't enough receptacles in the room, and everybody had to plug in their relocatable power taps into each other, right? Which, by the way, you're not supposed to do. If you ever read the instructions on those, they all say two things. Number one, it says, don't plug them into each other, which of course we've done. And then number two, it says, don't mount these to anything, which is awesome because they all have mounting holes in the back. But the instructions say, don't use them. So kind of a strange little thing. Little informational note here in 90.2 also says that hazards often occur because of overloading of wiring systems. Therefore, the initial installation should provide for increases and changes in the use of electricity. Now, this is kind of a mom's hugs and apple pie kind of code section. You know, it would be lovely if we could provide for future and changes in the use of electricity. I don't know how possible that is, so you know, the code just kind of says do your best. It would be cool if you left extra spaces in panel boards, things like that, extra capacity in the service, but we're not going to hold you to that because, you know, who knows what the future is going to provide. We're going to need more capacity, or are we actually going to need less capacity? So it's hard to say. 90.2C, what does the code cover? Super important section here. The code covers the installation and removal of conductors and equipment, including signaling, control, fire alarm, communication, optical fiber. The key word here, and in my opinion, perhaps the most important word in the entire book, is installation. The code covers installation. It's not a maintenance standard. It's not a usage standard. It's an installation standard. What you install needs to be compliant, right? If you're making an installation, you read the NEC. And when we look at the word install, you know, that's not defined in the NEC. So we just, you know, go to a regular dictionary. It says setting something up for use or service. For example, had an exhaust fan installed in the kitchen, or we installed some software. So looking at this photograph here, this would be an electrical installation, right? The garage door opener is cord and plug connected, but that's an installed piece of electrical equipment. So the code regulates that, and we have specific requirements for the control circuit that goes to the motor, for the power circuit that powers it up. But maybe something like a desk lamp. Do you really install these? Or do you just kind of put them on your desk and plug them in? Probably not regulated by the NEC. I don't think that's an installation. I think that's the usage of electricity, and we really don't cover the usage or the maintenance, right? We cover the installation. 90.3 tells us how the code works, and we'll just do this really quick. Chapters 1 through 4 apply generally to all installations, and then chapters 5, 6, and 7 modify those general rules. And then we have chapter 8, which is some communication stuff, which is kind of its own little book for telephone wiring and things. So, for example, in the chapters 1 through 4 rules, you have a rule that says, listen, for dwellings and for dwelling unit accessory buildings, you can use NM cable, Romex. But there's something in chapter 5 that modifies the rule in chapter 3, and that would be like for agricultural buildings. So yeah, you can use Romex for your accessory building of your house. Unless your accessory building is a barn, right? Then you can't, because agricultural buildings, you can't use it. So just an example of how chapter 5 modifies chapter 3, right? Chapters 1 through 4 apply generally. Chapters 5, 6, and 7 modify chapters 1 through 4. 90.7, examining equipment for safety. This is I don't want to say a rule, it's really just kind of a statement. It says some, but not all equipment is required to be listed by a qualified testing laboratory that has the proper equipment and expertise to test and inspect them. This is something that surprises a lot of people. Not everything in the National Electrical Code has to be listed. A lot of stuff does, but a lot of stuff does not. If you're familiar with the IRC and the IBC, the I codes tend to lean very, very heavily on product listing. Pretty much everything has to be a listed product. In the NEC, it's not quite that way. Some stuff does, other stuff does not. So here I have the mark of a certifying body. This one is Intertek. Could be UL, could be Intertek, it could be TUV and MetLabs and QPS and CSA. There's a million of them, right? We don't have to use any particular one, and sometimes you don't have to use any of them. The use of listed products helps prevent the inconsistent approval of products by different inspection agencies. So imagine if, as inspectors, we had to determine the suitability of every single product that gets installed. It wouldn't be possible. And quite frankly, we're not qualified to do it, and we don't have the facilities to do it. So we rely on testing agencies like UL and like Intertek, right? They can test the products, make sure that they're going to work properly, and more importantly, make sure they're going to fail safely, right? So the use of listed products really provides for consistent approval across the board. For listed equipment, the factory installed wiring and the construction of that equipment does not need to be inspected, except to check for alterations or damage. All right, so I don't need to get into this piece of equipment with a magnifying glass and start figuring out, okay, what kind of wire is that? Is that THHW or is that THHN or is that, we don't need to do that. It's a listed product. That means it's already been inspected, right? We just want to make sure it hasn't been altered or it hasn't been damaged. The last thing that it says here in 90.7 I think is kind of important. It says listed equipment, the suitability of the product needs to be determined by applying requirements that are compatible with the code. Okay, so in order to have a product listed, there has to be a product standard, right? And the product standard is going to say how the product is supposed to perform. It must have an ampacity of this many amps, and it must not exceed this temperature and what have you. And then we send our products over to UL or Intertek or whomever, and they test it and make sure it complies with the product standard. But they're also supposed to ensure that it complies with the National Electrical Code. It could be a totally safe product, but is not recognized by the NEC or is not code compliant. And if that's the case, it really shouldn't get listed. But if it does, that's really no guarantee that it can be installed, right? It has to comply with the NEC, even if it is a listed product. All right, Article 110, general requirements. So Article 110 is a huge article, and I normally do like a full 8-hour class just on Article 110, but we're just going to do a couple of sections here today, and then we'll wrap up. So 110.2 approval. All conductors and equipment need to be acceptable to the authority having jurisdiction. Okay, so the authority having jurisdiction is the NFPA's term for what the I codes would normally call the code official, right? So the authority having jurisdiction is the person or the people that are responsible for enforcing the code. And this section says, listen, everything has to be acceptable to the authority having jurisdiction. So how do I know that these breakers are going to be acceptable then? Well, probably the easiest thing to do is to check if it's listed. Now, circuit breakers, believe it or not, up until the 2023 NEC, circuit breakers did not have to be a listed product. And now they do, so I can look at the UL mark there and I can say, okay, it is listed and it's probably suitable, right? But if that wasn't a listed product, how would I as an inspector know that that thing is going to behave safely? How would I know when it's going to trip, if it's going to trip at 20 amps or 2000 amps or maybe not at all, right? So all things must be acceptable to the authority having jurisdiction, and listing goes a long way to help that process. But of course, the code can't talk about everything, right? So here we've got this, this temporary installation. A friend of mine, an inspector in Salt Lake City, sent me this picture. They went out to do this inspection, and believe it or not, they were supporting this temporary wiring with a bucket of ice, which I guess kind of puts a time limit on it. You know, at least I know this thing's not going to be here all year. You know, this project better be done by April or so. But you know, the code doesn't really talk about whether or not you can use a bucket of ice. So it does rely on the authority having jurisdiction to make a decision, right? So things have to be approved, and that's where 110.2 comes in. 110.3 kind of works hand in hand with that. Examination, identification, use, and listing or certification of equipment. When we're looking at equipment, 110.3a kind of talks to the inspector mainly, but also to the specifier or designer. It says when we're determining approval of equipment, the AHJ needs to evaluate a couple of different things. Number one, we need to figure out, does this stuff even comply? That's probably the first question that needs to be asked. Suitability for installation and use in compliance with the code. So here I've got this liquid tight flexible metal conduit. Now I mentioned not everything has to be listed, but liquid tight flexible metal conduit does have to be listed. And here we've got this product, and this just cracks me up every time I see it, but it actually says non-UL, right? So they're actually advertising the fact that this is not listed. You're thinking, well, where can you use that? It's not listed. You can't use it. Well, for use in applications where agency approvals are not required. I guess that means you can't fail inspections if you don't get a permit. You know, I mean, I'm not quite sure where they're going with this. You know, maybe if you were an equipment manufacturer, you could use this as part of manufacturing the equipment, but you certainly can't install this stuff, right? Item one, you got to figure out, does this stuff even comply? Number two, we need to consider things like mechanical strength and durability, wire bending space, electrical insulation, heating effects under normal and abnormal conditions. So here we have an example of a panel board, which is the guts, and the enclosure that it's in, and they're not listed together. But that's okay, because they don't have to be. So how do I know that that's going to be a safe installation? Well, that's where you go back through 110.3a, and you can kind of use it as a checklist. You can say, okay, number one, does this comply with the NEC? Yes, panel boards have to have a dead front and they have to be in a box. It is. Mechanical strength and durability, wire bending space. Looks like we got all sorts of space. Electrical insulation, heating effects, right? Arcing effects, voltage type, size, ampacity, specific use. All of these things need to be evaluated when we're looking at electrical equipment. This switch right here is what we would call an explosion-proof switch or a dust ignition-proof switch. It's actually both. And looking at that, I mean, that's just a light switch in a hazardous location. That probably is going to be suitable for just about anything, but we would have to look at the whole label And it says, okay, class 1, groups C and D, class 2, groups E, F, and G, class 3. Well, you know, there actually is a class 1 group A and a class 1 group B, and this doesn't appear to be suitable for those. So we need to consider things like specific use when we're evaluating equipment. New to this version of the NEC is something that we've never really talked about before, and I think this is interesting. The code says you have to do this, or at least you have to consider it. Doesn't quite tell you how to do it, and I don't know that it can. It says cybersecurity. Cybersecurity concerns for life safety connected equipment that's connected to a network, including malicious attacks and unauthorized changes, as well as the ability to continue to perform correctly and safely. You know, this piece of equipment here is not your grandma's switchboard. You know, a modern switchboard today, you can buy them with a full-blown Windows operating system. And, you know, I guess we have kind of a gorilla in the room. I mean, the elephant in the room, rather. I mean, 2 days ago, whenever it was, we had that massive outage, right? Imagine if this was a hospital. And that, you know, we've got this system here where you can log into it with your username and password and change the characteristics of the circuit breakers. Now, that's fine. There's nothing wrong with that. We can walk up to a lot of breakers and do that with screwdrivers, right? They're designed to be adjustable. If I can do it with a username and password and I log into it, okay, fine. What if I can do it from my phone? Well, if you can do it from your phone, then maybe a bored teenager could also do it from their phone, you know, and knock down a customer-owned substation for a hospital or something like that. So new to the 2023 NEC, we're saying, listen, you need to consider cybersecurity. We don't know how to tell you what to do. We're just going to tell you that you have to do it because, look, we're not computer people. We're electrical people. We're not going to tell you how to fix this. We're just going to say, listen, it's something you need to consider. Other things you need to consider, other factors that might play a role in electrical safety. You know, you look at this installation here and you go through the checklist and yeah, that's probably not suitable for this specific application, right? Other factors. 110.3b is a pretty simple section now. For years, it said equipment that's listed or labeled has to be installed in accordance with the manufacturer's instructions. In the 2023, they made a change to say equipment that's listed or labeled or identified. And identified is a weird word in the NEC. I got to be honest, I'm not in love with the definition. But basically, identified means that it's suitable for a specific application. So if you think about it with that in mind, now the code for the first time is really saying that you always need to follow instructions. So perhaps that's something that should have been in the code forever, but now it is. So we need to make sure we're following manufacturers and listing instructions. The listing itself needs to be performed by a qualified testing laboratory, and the testing must be done on a recognized product standard in order to ensure safety. So yeah, you know, junction boxes don't necessarily have to be listed. I don't think using a tuna fish can is really the right solution either. And by the way, if you're going to write UL listed on your tuna fish can, the least you could do is draw a circle around the UL, you know, at least make an effort at deception, you know. So anyway, I just kind of find that picture amusing. There's a little note here as well that says OSHA's NERDL program, the Nationally Recognized Testing Laboratory Program, recognizes qualified testing laboratories. So a lot of times we'll say, okay, something has to be listed, fine. I've got this mark that says ETL or UL or TUV. How do I know that that is a qualified testing laboratory? Well, the NEC doesn't tell you this. It says, look, OSHA would be a good place to go. We can't tell you you must go to OSHA, but we can give you guidance and we can say, you know, they're kind of the keepers of the recognized testing laboratory. So if you go to OSHA, they've got a list of testing laboratories that they consider suitable. So UL, MetLab, CSA, ETL, right? All of these different testing laboratories. All right, changing gears a little bit. 110.8 wiring methods. Only wiring methods that are discussed in Chapter 3 of the National Electrical Code are permitted to be installed. Believe it or not, You can't just put a pool noodle over your wires and call it conduit, right? It actually has to be something recognized in Chapter 3 of the National Electrical Code. And unless specifically indicated otherwise, any wiring method is allowed in any building or occupancy or premises wiring system, but it has to be a real wiring method, right? You can't just take wires and run them through a wall. You know, it's got to be in a conduit or a cable bus or a cable tray, right? So we want to make sure that it's an actual listed wiring method in the NEC. But out of those wiring methods in the NEC, you can use any of them anywhere unless specifically prohibited. So where can you use NM cable, for example? Where can you use Romex, right? Where you can wire houses with it, certainly. Can you use it in multifamily? Well, yes, you can use it in multifamily if it's allowed to be type 3, 4, or 5 construction. If it's type 1 or 2 construction, right, concrete and steel, it's a non-combustible building, man. We don't want combustible wiring methods. We want to have steel conduit in there or something, right? So you can't use NM cable in multifamily unless it's permitted to be type 3, 4, or 5 construction. In other than dwelling units, so commercial buildings, can you use NM cable there? Well, yes, if it's allowed to be type 3, 4, or 5, and it's concealed behind a 15-minute finish rating. Again, the combustibility issue. So we want it behind drywall, right? We don't want it out there where the flame spread and smoke development is just going hog wild and lighting everything on fire. Another example of some specific applications might be if I'm doing hazardous locations, right? What kind of wiring can you put in a room that looks like this? Well, the answer is not much. You know, when it comes like this, we're pretty much looking at using threaded conduit, right? Rigid and IMC. There's a couple of other exceptions as well, but certainly rigid and IMC are going to be the most popular methods in what we call a class 1 location like this. So you can see between the switch and the thermostat, I've got a fitting here that is called an explosion-proof seal fitting. And that makes sure that because that conduit and all those enclosures, they're going to be filled with combustible or flammable vapors, right, from all of these gasoline tanks here. Inside of that switch box, what happens when I walk into that room and I turn on the light switch? You ever walked into your room at your house and you turn on your light and behind the light switch, you can see like a tiny little blue pop? It's kind of cool. It's a series arc that's happening. Not enough power to really do much, but it's kind of fun when you see that happen. Not so fun when you see that in a room like this, right? The last thing you want to see is a little arc or a spark when you turn on the light. So because of that, we use what's called explosion-proof wiring. Not because the wiring is explosion-proof, but because the wiring won't explode the building, right? So inside that switch box, when I turn that switch on, you can see how that thing is constructed, right? You don't buy that thing at Home Depot. When you turn that little guy on, if there's a pop inside of it, that little explosion is contained to inside that box, right? And we have to use special wiring methods to ensure that we don't blow up the rest of the building. So that would be an example of where rigid or IMC might be the appropriate wiring method as opposed to Romex or MC cable or anything like that. 110.11, deteriorating agents. Kind of a simple rule here, but an important one. It says conductors and equipment in damp or wet locations, or where exposed to gases, fumes, vapors, or extreme temperatures, must be identified for the location. All right, so we're installing outdoors. We want to make sure we're using outdoor rated equipment. Pretty simple, right? When it comes to just outdoor stuff, you know, if you're installing in Utah, like where I live, well, this is probably something you're going to have to deal with. If you're installing in Florida, probably not something you're going to have to consider. But you might have to consider salt water in Florida, where I don't have to consider it here. So we need to make sure that we're installing equipment that's designed for the atmosphere in which it's being installed. So, you know, maybe if you're on the beach in Florida, maybe stainless steel might be a really good solution, or PVC coated steel conduit as opposed to just regular galvanized steel products. So always make sure that we're installing things that are suitable for the location in which we're installing them. The last thing I want to talk about today in part 2 of Article 210 is section 110.26. Spaces around electrical equipment. You know, when I wore the tools, this was one that I always figured if I had a chance to talk to architects, this is the rule that I would talk to them about, and that is working space, right? How much space do you need around electrical equipment? And I understand it's a difficult one because, you know, equipment spaces, you got to have them, but they don't really make you any money in your building. You know, you're not leasing it out and everything else. So I understand people don't want a huge, you know, electrical room. So what are the rules? I mean, how big does the electrical room have to be, or do you have to have an electrical room? Well, working space and access to and egress from that working space are required around all electrical equipment to allow for safe operation and maintenance. All right, so you can see that we added some words here, access to and egress from it. And really that was just kind of an editorial issue because this section in 110.26, it talks about access and egress. So in the opening statement here, it probably ought to say what the rest of the section is going to talk about, right? So access and egress. But here's the bottom line. This rule stands on its own. It says all equipment must ultimately be capable of being operated and maintained safely. So how much space you need in front of a given piece of equipment might vary based on what that equipment is. And we don't really do a great job of telling you in the NEC that you need 3 feet in front of a panel board, and you need this in front of a transformer, and you need this in front of a disconnect, because what's a transformer, right? If I were to say, okay, you need 3 feet in front of a transformer. Well, maybe we're talking about a transformer like the one in the bottom of this photograph. Or are we talking about one of the great big green ones out in the parking lot? Or are we talking about a doorbell transformer, right? That's in your house. So I can't say you need 3 feet in front of a transformer because what's a transformer, right? So what this ultimately says is, listen, everything has to be capable of being worked on safely. That is a rule that stands on its own. And then more specifically, we'll get into some of the other rules here momentarily. So certainly this is going to be a violation, right? Obviously, you can't work on that equipment safely. I would say you can't even access it or egress from it safely. Huge, massive, big deal change in the 2023. Open equipment doors must not obstruct access to and from the working space. All right, well, I think on paper, this rule makes a lot of sense and it provides for a lot of safety. In that piece of equipment right there, normally what happens is when you open those doors, these little pins drop down in the bottom of the doors and they lock them in place at a 90-degree angle. So maybe you've got 4 feet between the front of that equipment and whatever it is that's behind you, a masonry wall or something, right? You got 4 feet, plenty of space. Well, what if those doors are 3 feet and they lock in place when they're open? And even if you were dressed in personal protective equipment, what if something went wrong while you were working on that equipment and we have an arc flash event? I would have to try to squeeze my fat bottom through a 1-foot little opening while I'm dressed like an astronaut to escape that. And let's be honest, it's probably not going to happen. So this really adds a lot of safety. But it also can be problematic in the design arena. So open equipment doors must not obstruct access to and from the working space. Now, in the 2024 or the 2023 NEC, we clarified what obstruction means. Access/egress is considered obstructed if one or more open equipment doors reduces access to or egress from the working space to less than 2 feet wide and 6.5 feet high. So looking at this picture, we're going to have to measure with both of those doors open. And I've got to have those doors miss each other plus 2 more feet. Now, in an installation like this, that's a big deal. That's switchgear row 1 of 8 in that room. That room probably has to be 20 feet bigger than it did before, unless those doors have like piano hinges that open a full 180 degrees. So be mindful of this new rule in the 2023. It is a big, big deal. Open equipment doors must not obstruct the means of egress. Now, when I say means of egress, I don't mean Chapter 10 IBC exit discharge. I'm not talking about that. I'm saying your ability to leave the working space in front of the equipment, okay? It's not obstructing, you know, the exit access corridor and all of that jazz. 110.26, general statement says, look, everything has to be capable of being worked on safely. More specifically, A says for equipment likely to require examination, adjustment, servicing, or maintenance while it's energized, working space must comply with A1 through A4. Now, that can be as simple as a person measuring voltage, right? That is examination while energized. Most people are going to say that panel boards like these will be examined while energized, at least at some point, right? Even if that's just measuring voltage. We have to troubleshoot things sometimes. So these have to comply with 110.26 A1 through A4. A1 is the depth of the working space, and it depends on the voltage and what's behind you as you're looking at the equipment. So at a minimum, 3 feet, but sometimes 42 inches or even 4 feet, again, depending on the voltage and what's behind you. So at a minimum, I need to have 3 feet by 30 inches wide, but not less than the width of the equipment. Now, that working space does not have to be centered. You can put a panel in a corner, right? Push your tape into the corner and pull it 30 inches. As long as you have 30 inches and the full width, you're okay. The height of the working space, minimum 6.5 feet, but never less than the actual height of the equipment. Here's what I want you to think about. You need to basically be able to take an empty refrigerator box, put it in front of your equipment, right? Your panel board, your switchboard, your switch gear, potentially your transformers, depending on the installation and what size the transformer is, right? Whatever is likely to be worked on while energized. New to this edition, the working space needs to be as level and flat as is practical. So here in this photograph, probably could be more flat than that. And I think it would still be practical to make that more flat. So it does need to be more flat. Doesn't say it has to be level and flat. Otherwise, you couldn't mount things to an exterior wall, right? Because you have to have drainage. So it just says as flat and level as is practical. Got to have at least one entrance to get to the working space. Makes sense. Here's my gate. That gets me there. For big equipment with overcurrent devices, switches, or control devices, you've got to have a 24-inch wide by 6.5 foot high or bigger entrance / exit at each end of the working space. What we do not want is a corridor like this that could have an arc flash and trap an employee there. Okay, so this individual needs to be able to get out of the working space on each end. Now, again, I want to be very careful here. This does not require a Chapter 10 IBC means of egress from each side, right? If this guy can walk to the end of that picture and, if at the end of this row of switchgear, if he can get past the switchgear by at least 2 feet, he can have a brick wall on his left and his right. That complies. You just have to be able to leave the working space on each end of the equipment if the equipment is bigger than 6 feet wide and is rated 1200 amps or more. So on this picture here, you need to be able to leave it on that side and leave on that side. Or, due to the 2020 code, if the equipment is the service equipment, which is the first place you can shut off the utility, and the sum of the service disconnects is 1200 amps or more, and the combined width exceeds 6 feet. All right, so looking at this picture here, each of those that I'm pointing at are 600 amps, total of 1200 amps. I need to have an exit on each end of the working space. But again, all I have to be able to do is just leave the working space. So looking at this picture here, if I'm in front of this equipment, I can walk 2 feet down here and I'm out of the working space. If I'm standing up here, I can walk up here, I'm out of the working space. That complies. Even if I were to take this wall and run it all the way down, it still complies. You don't need a Chapter 10 exit from each end. You just need to be able to leave the working space on each end in case that thing shoots a fireball at you. You just don't want to be in front of the fireball. The last thing, equipment rated 800 amps or more that contains overcurrent devices, switching devices, or control devices, any personnel door intended for entrance or exiting to and from the working space must open at least 90 degrees, makes sense, and it has to have listed panic or fire exit hardware if it's within 25 feet of the equipment. And I thought I had it written down here. I guess I don't. It needs to swing out as well. It needs to swing in the direction of egress. This is one that can really play havoc with your design, right? If this is going into an access corridor, means of egress corridor, and it swings out, you guys know more about reducing the exit width than I do, but it is something that you need to be considerate of. The very last thing we're going to talk about today, 110.26e, dedicated equipment space. This section tells us that switchboards, switchgear, panel boards, the service disconnect, and any motor control center has to be provided with what we call dedicated equipment space. And what that is directly above the equipment, just the footprint of the equipment, right? 20 inches wide by 6 inches deep or whatever, measured from the floor to the top of the equipment plus 6 feet. That space is for electricians only. No ducts, no plumbing, right? None of that stuff. From the floor to the top of the equipment plus 6 feet, or to the ceiling if the structural ceiling is lower than 6 feet. That space is for electricians only. All right. I was hoping to get through that by a quarter till, and it looks like I took one more minute than I planned on. So I think we have some questions in the chat board. I would love to address those now. So I don't know how you want to do this, guys. If you want to read them to me, or what you want to do.
Yeah, I am happy to just kind of read them through and start at the top. All right. So Brian asks, what was discovered to be the culprit of the low voltage event shown in the early slide?
Yeah, great question, Brian. So that was a low voltage lighting system, not a, it was not what we would call class 2, which is a very, very, very low voltage. This was one of those lighting systems. You sometimes see it in restaurants where it has the 2 conductors that go through the ceiling, right? That are kind of parallel to each other, and the lights that hang off of them. It's a 25 amp transformer, and 24 volts is not enough to kill you with electric shock. 25 amps is enough I²R power to light the building on fire. And basically what it was is within that transformer, there was a failure. And I think what it did is it put primary voltage through to the secondary. And the splice that I took a picture of was not in a box. It was just an open splice because the electricians figured, it's low voltage, who cares? Well, as we turned out, obviously we should have cared because it was a problem. But yeah, the ultimate cause was the equipment malfunction. It was the transformer.
Mhm. All right. What are some examples of 2-inch thick concrete or equivalent in table 300.5 minimum cover requirements?
Okay, yeah, that's interesting.
Yeah.
Yeah, so 2 inches thick of concrete or equivalent in table 300.5A. I'm trying to recall exactly how that phrase is used, because 300.5A is how deep you have to bury underground wiring, right? So if it's in a trench below 2 inches thick concrete or equivalent, I mean, personally, and this is just me talking, I would consider asphalt to be equivalent, because all we're trying to do here is protect the underground wiring from somebody digging it up, and if you're going to be digging up concrete or you're going to be digging up asphalt, either way, you're going to have to make an appointment for that, right? You're not going to just get out your shovel and go to town and injure this raceway. So in my opinion, for that application, I would call asphalt equivalent. Brick, something like that as well.
Mhm. All right. Does walking into another working space comply with exiting a working space?
Great question. So yes, I think it does ultimately. If you have that big equipment, 1200 amp, 6-foot equipment, and you need to exit it on either side, if you walk into the working space of a different piece of equipment, then in my opinion, yes, you have satisfied that requirement. In that one picture, we had like the big, huge, long row of switchgear. I'm going to view that as one working space. So to go from what we would call the one section, the one bucket of switchgear, and walking into the next bucket of switchgear, I don't think you've exited the working space in that regard. But if you're leaving the working space of this equipment and going to somewhere else, then I think you have satisfied the rule. Yeah. Because that one piece of equipment can have an arc flash and it can propagate, right? So inside of that equipment, especially if it's 277, 480, not lower, not higher, but 277, 480, inside of it, that arc will propagate. It'll start to arc and it will ionize the air inside of it. And what starts out as just a little ground fault ends up being a phase to phase to phase to ground to neutral, three-phase fireball, you know, the whole ball of wax. And in fact, that's why we have to have ground fault protection of equipment only at 277, 480. So you have to be able to leave the working space of that whole equipment, because that propagation can occur and start as a fireball over here and end as a fireball over there. But if you've left the working space for that equipment, then you've left the fireball.
Mhm. All right. Okay, this is another bit of a long-winded one. Incidental uses according to section 509 of the IBC requires electrical installations and transformers potentially be provided with fire separations. Understanding that there are many variables that come into play, is there a general rule of them when fire separations are required specifically at electrical rooms?
Oh, that's interesting. So I can't speak to section 509 of the IBC. I used to be an inspector, but it was 10 years ago, so I haven't opened the IBC in probably 10 years. If you have what I would tell you is in the NEC, very seldom we have to, but sometimes we'll have to have what we call a transformer vault. And a transformer vault is like when you have an open transformer, okay? Not a transformer in a box, just like the things you have on the pole, but they're in a building and you got wires coming straight out of them. That oftentimes has to be installed in what we call a transformer vault.
Mhm.
Or if you have a regular transformer, there's some criteria sometimes that says it has to be in a 1 hour room, but the exceptions in 450.13 usually get you out of that requirement. So it's really not that often that you have to have fire resistance rated construction around electrical equipment. It's very seldom.
All right. Does the wall panel next to the dishwashing equipment need to be ground fault protected?
Interesting. I'm guessing we need the panel board that's on a wall. I think you're talking about that photograph that I had, Brian. I had the stainless steel enclosure. The answer to that is no. We only require ground fault circuit interrupters for the outlet, which is usually the receptacle outlet, but sometimes it could be the hardwired equipment. That's also connected at what we call an outlet. But no, the panel board itself does not require any sort of protection.
Okay, great. When are 1 hour rated walls required around electrical rooms?
Kind of already answered that one, really, I think. You know, again, if I went back to Article 450, and I said 450.13, but I know 450.21 is what I should have said. So in 450.21, for big transformers over 112.5 kVA, you're supposed to have a 1 hour room, but there's two exceptions to it, and they're specific to the transformer, and you always meet those exceptions. Modern transformers, the way they're built, they pretty much always get you out of those exceptions. So very, very seldom do you need it.
All right. What is the difference between an electrical room that requires 1 hour versus 2 hour construction? UPS battery rooms typically require the 1 hour. Are there any 2 hour requirements for electrical rooms?
The only time that I can think of is when you have medium voltage transformer vault. And a transformer vault is supposed to actually be 3 hours, not just 2. So if you look at in the NEC at 450.42, there's some criteria there that requires it. But transformer vaults really aren't that common either.
Mhm. All right, last one here. This looks like more of a comment, but we'll just kind of read it out loud. Patrick says, don't forget no other trades such as plumbing above electrical equipment, such as panels.
100%. And me as an ex-electrician, that was always a big deal for me, because I can have all the space in the world, but if you run a 24-inch duct above my panel, you might as well take the panel board and throw it in the garbage because I can't run wire out of it. So yeah, great point.
All right. Any comments or pointers on EV cars and bikes within building?
Oh, now that's interesting. So, I got to be honest, electric vehicles, cars and trucks, they don't frighten me. You know, I mean, a lithium ion battery fire is a very scary event, no question about that. But they are infrequent enough that I don't lose any sleep over them. You know, people point to the garage and say, "Oh, I wouldn't park a vehicle in there." Well, you got an internal combustion engine in there. How many gasoline fires have we had, right? So don't be paranoid about electric vehicles. But you mentioned specifically bikes, those little things, right, all around the city, right, where you just drop them off wherever and whoever picks them up. Those things are a problem. There are hundreds of fires, and I'm not exaggerating, hundreds of fires every day from those bikes. I saw a statistic in New York City alone, in the five boroughs, they have an average of 4 EV personal vehicle fires every day, just in the city. So those things, yeah, I would not be putting those in my garage or in my house. You know, a lot of it has to do with counterfeit listing and things like that. So be careful indeed with those little guys.
Mhm. Awesome. All right. It looks like that may have taken care of all of our questions. Oh, one more came in and we've got a few minutes left. So,
Mhm.
this is more of a suggestion.
Yeah.
But this person is asking to see a video of an arc fault event so that we could see what that looks like. Yeah.
So with arc flash events, I kind of have I really vacillate on that because I'm not going to show somebody dying. That's just something I'm not going to show. You know what I mean? But it is worth remembering that the stakes are very high with what we do, man. When in our industry, when something goes wrong, it goes very wrong very quickly, and you can't react to it. By the time the event has started, it's almost over already, right? So there is no reaction. I can show a very quick video if you want, Bill. We got 2 minutes. It's a 20-second video. You want me to throw it up?
Yeah, go
Let's
for
do
it.
it. Let's do it then. Let me just quickly find it. Promise it won't take very long. Work stuff, videos. Here is a video. Here's an arc flash incident. So 3 people in this video working on an emergency system switchboard. This is de-energized when this video starts, and 1 in a million chance they are in this equipment, the utility power shuts off, the generator kicks on and turns on the equipment. So they didn't have the generator locked out, and that's what caused this.
We're not
So,
seeing it playing, so I think
oh, you're not seeing it play.
you might have to like switch the screen you're
Was
sharing.
I showing? Oh, I'm an idiot. I was showing the wrong screen.
All good.
Well, let's do this then. We'll slide it over this way.
There we go. Oof.
Yeah, pretty gnarly.
Yeah.
So that one, of course, was awful. You know, 3 people involved in that incident. And like I say, I've seen videos. You'll see his pants are still on fire here. It shoots up here in just 1 second. I've seen videos that are far more shocking, and I try not to show them because, like I said, I don't want to. There's a big difference between it being informative and being exploitative. You know, and that's a line that I tend to take pretty seriously. So. Yeah, but great comments though. You're right. There is value to seeing something like that, you know, if you're not exploiting it.
Yeah. Awesome. Well, we've got about a minute left. So I just want to thank everyone so much for joining today and for asking such great questions. We appreciate your attendance and your engagement. And thank you, Ryan and Dale, for a really awesome, informative presentation. Quick note to everyone as you're leaving today's webinar, there will be a quick post-event survey. If you've got some time to fill that out, super helpful for us. You can also leave any questions or comments that you have for Ryan and Dale on that as well.
Awesome.
right.
Thanks for having me, and I hope you guys enjoyed it. Great seeing you.
Yeah, great to see you too. All right.
Thank you all.
Thanks, everyone. Have a good one. Bye.
Bye.